Okay, so for this problem, it's a beautiful problem. I'm going to go through it to show you how I would go about doing a normal distribution problem from start to finish. So it says here, if birth weights in a population are normally distributed with a mean of 109 ounces and a standard deviation of 13 ounces. So the first thing I'm doing is I'm actually putting the normal distribution with a mean of 109 ounces and a standard deviation of 13 ounces. So I'm putting that information at the top to begin us. What is the chance of obtaining a birth weight of 141 ounces or heavier when sampling birth medical records at random? Okay, so what I'm calculating is what's the probability of getting a birth weight that is greater than or equal to, and it doesn't really make a difference, but I'm going to put that 141 ounces or bigger. That's really what I'm calculating. So that's the first thing that I'm going to do. Next, I'm going to do exactly the steps that I've showed you guys. I'm going to draw a picture first. So I'm going to draw a picture. And from here, I'm going to put the mean right in the middle. The mean is 109 ounces. And then I have 1, 2, 3 standard deviations this way. 1, 2, 3 standard deviations this way. And what I'm going to do is I'm actually going to take my 109. I'm going to add 13 ounces. So this would be at 122, 1 standard deviation away. I'm going to add another 13 ounces. I'm at 135. And finally, adding another 13, I'm at 148. It actually shows me that if I'm talking about 141, it's going to be up here somewhere. So I know just by looking at it that this is a high birth weight. It's a high birth weight because I'm looking at 141, which is going to be way up here. And what I'm wondering in this question is they say specifically, what percent weigh more than this? This is going to be a pretty small percent when I look at the problem. This is where I shade. So step 2 is going to be to shade it. Had I had a negative birth weight, like smaller, I would have gone the other way too. So I would have taken that 109 and subtracted 13 to get 96, subtracted another 13 to get this one, another 13 to get whatever that weight is. But I'm not going to do that because I know that I'm looking at a value way up here. Okay, so now that I've got that, and I should end up with a small percent that are actually heavier than that 141 ounces, I'm going to calculate the problem. So I have to find the z-score. So step 1 is done, draw it. Step 2 is done, color it. Step 3 is going to be to calculate my z-score. My z-score, I have to take this distance from the mean, 141, minus my mean of 109. And I divide by the standard deviation of 13. This is going to tell me how many standard deviations away this value is. So I take 141 minus 109, which is 32, and divide by 13. I get approximately 2.46 as my z-score. 2.46. Okay. The final step is going to be to look up what that means. So what that means in my table, and I need to find my table. I had it a second ago. Here it is. When I look up a z-score of 2.46, 2.4, and I follow it over 6, it's right here. I get 0.9931. 99% is what that means. 0.9931. That's my area to the left. Always to the left, to the left. So that's always the area to the left. I don't want the area to the left. I want the area to the right. I want to know specifically what is the probability of getting a value greater than 141 ounces. So the way I calculate that, I'm going to actually write it. 141 is this entire area is 1. So I'm going to take 1 minus my 99%. 1 minus my 99% that I just looked up. 1 minus 0.99, and I get about 1%. About 1% of babies were heavier than 141 ounces.